Imagine wearing a device smaller than your thumb that can separate a whisper from city traffic in real time. But here's what nobody tells you. This tiny machine begins its journey thousands of miles before anyone ever wears it. Most people never think about the rare materials hidden inside, yet each one plays a life-changing role every single day. Inside something weighing only a few grams, engineers pack thousands of microscopic components with astonishing precision. Think about this. One misplaced component thinner than a human hair can silence the entire device. Every hearing aid must survive sweat, dust, accidental drops, and years of everyday life without missing a single sound. And this is where it gets truly extraordinary. Many factories build millions of these devices with nearly zero room for mistakes. Each finished unit carries technology powerful enough to process sound thousands of times every second inside your ear. What happens next surprised even experienced engineers, because the hardest challenge isn't making it small, it's making every sound natural. Before the first circuit exists, the journey begins deep beneath mountains, deserts, and ancient rock formations across several continents. Copper, silicon, gold, specialty plastics, and rare minerals all travel incredible distances before meeting inside one remarkable device. Some materials cross oceans more than once before reaching the factory, where precision finally transforms them into life-changing technology. The supply chain looks almost impossible, yet every shipment must arrive exactly on time to keep production moving. But one hidden ingredient changes everything, and without it, the world's most advanced hearing aid would never come alive. In the next stage, we'll follow that extraordinary material into the factory, where invisible precision becomes the sound of someone's future. As those cleanroom doors open, every worker follows strict contamination rules because even microscopic dust can ruin an entire production batch. The heart of every hearing aid starts with silicon, refined from quartz sand until it reaches extraordinary electronic-grade purity. Much of the world's high-purity silicon comes from advanced refining plants before becoming the tiny processors hidden inside these devices. Gold arrives next, often mined in Australia, Canada, China, and Peru, where its unmatched conductivity justifies every precious gram. Each hearing aid uses only tiny amounts of gold, but those microscopic connections must perform flawlessly for many years. Copper begins its journey in enormous mines across Chile, Peru, and the United States before engineers refine it into precision conductors. Special engineering plastics travel from chemical manufacturing plants, ready to become lightweight shells that disappear comfortably behind your ear. Medical-grade polymers resist sweat, skin oils, sunlight, and daily wear while keeping the device surprisingly light and durable. Inside the microphones, incredibly thin diaphragms detect vibrations thousands of times smaller than the width of a human hair. Tiny rare earth magnets help miniature speakers reproduce speech clearly, while fitting inside spaces barely larger than a grain of rice. Most people never realize dozens of suppliers across multiple continents must deliver every single part at exactly the right moment. A delayed shipment of one tiny electronic component can pause an assembly line producing thousands of hearing aids every day. Manufacturers inspect every incoming material long before production begins because hidden defects cost far more than careful preparation. Only after hundreds of inspections do these ordinary-looking materials earn permission to enter the precision assembly floor. And this is where everything changes. Because in the next stage, lifeless materials transform into intelligent machines that restore one of our most precious senses. Now the real manufacturing begins, where thousands of microscopic parts come together with astonishing speed, precision, and almost zero room for error. Everything starts with a multi-layer printed circuit board, or PCB, barely larger than a postage stamp, but packed with hidden pathways. A stainless steel stencil spreads lead-free solder paste across the board, creating thousands of microscopic connection points in just seconds. The paste contains microscopic metal particles and flux that will permanently bond every electronic component during the heating process. Next comes the fastest machine in the factory, placing tiny components faster than a human eye can comfortably follow. Vacuum nozzles lift resistors, capacitors, processors, microphones, and wireless chips before placing each within fractions of a millimeter. Modern placement systems can position more than 60,000 components every hour while constantly correcting their own alignment. Powerful cameras inspect every placement instantly, rejecting even the smallest error before the next component ever arrives. Now the boards enter a reflow oven, where temperatures gradually climb to nearly 245 degrees Celsius. Inside carefully controlled heating zones, the solder melts, flows, and solidifies into permanent electrical connections within just a few minutes. As the boards cool, thousands of invisible electrical pathways suddenly become one functioning electronic brain, ready for its next challenge. But the circuit alone cannot restore hearing, because its most delicate components still wait for painstaking assembly by machines and skilled hands. The finished circuit now meets the tiniest parts of all, where every movement demands extraordinary precision and a perfectly steady hand. Robotic dispensers apply microscopic drops of medical-grade adhesive, securing delicate microphones and receivers without adding unnecessary weight. Workers inspect every connection through high-powered microscopes, catching imperfections almost impossible to notice with the naked eye. Ultra-thin flexible wires connect microphones, receivers, antennas, and processors inside spaces smaller than the tip of your little finger. The shell closes with remarkable accuracy, sealing advanced electronics inside a lightweight housing built for years of everyday comfort. Now software takes over, transforming silent electronics into an intelligent system that understands and processes the sound around you. Engineers install firmware, calibrate microphones, and verify wireless communication before every device earns approval for acoustic testing. Inside soundproof chambers, precision speakers reproduce whispers, conversations, music, and traffic noise to measure the hearing aid's performance. Sensitive microphones compare every output against reference signals, ensuring speech stays clear while unwanted background noise fades away. Each battery undergoes charging, discharge, and safety verification before technicians install it into completed hearing aid. Finished units face moisture, vibration, temperature, and repeated button tests to simulate years of daily use within only hours. Some factories even perform automated drop tests, making sure accidental slips won't end the life of these remarkable devices. Only the devices that pass every electrical, mechanical, and acoustic inspection receive their unique serial numbers and final approval. At last, each hearing aid rests inside protective packaging, ready to help someone reconnect with voices, laughter, music, and everyday moments. But before a single customer ever opens that box, one final challenge waits, where artificial intelligence and human expertise compete to find even the tiniest hidden flaw. Before any hearing aid reaches a patient, it enters a factory's smartest department, where artificial intelligence searches for flaws invisible to people. High-resolution cameras capture every surface from multiple angles, creating detailed digital models within only a few seconds. Laser scanners measure dimensions with tolerances as small as 20 microns, nearly 1/4 the width of a human hair. If a shell sits even slightly out of alignment, automated systems immediately remove it before final packaging begins. Machine learning software compares every inspection against thousands of approved examples, becoming smarter with every device it examines. But here's what nobody tells you. Experienced technicians still catch subtle defects that algorithms occasionally miss. That combination of human judgment and intelligent automation creates reliability that neither could achieve completely alone. Every microphone undergoes acoustic calibration inside silent chambers designed to eliminate echoes and outside interference. Precision instruments measure frequency response, distortion, feedback suppression, and amplification across hundreds of carefully controlled sound levels. Engineers verify Bluetooth performance by transmitting data repeatedly, ensuring stable wireless connections in everyday environments. Rechargeable models complete repeated charging cycles, confirming their batteries maintain dependable performance over years of regular use. Environmental chambers expose every design to freezing cold, intense heat, humidity, and constant vibration before approval. Some manufacturers aim for rejection rates below 1%, proving that precision begins long before customers ever open the box. International standards demand strict documentation, allowing every component to be traced back to the entire manufacturing process. Every approved hearing aid receives a final digital identity, recording inspection results, calibration data, and production history forever. Most people never realize that every tiny device carries a complete manufacturing story hidden behind one simple serial number. And this is where the story becomes even bigger, because these tiny machines support millions of lives across an enormous global industry. Today, millions of hearing aids leave factories every year, helping people reconnect with conversations, music, and the sounds that shape everyday life. The global hearing aid market is worth tens of billions of dollars and continues growing as populations live longer than ever. Leading manufacturers operate advanced production facilities across Denmark, Switzerland, Singapore, China, Mexico, and the United States. Thousands of engineers, technicians, software developers, and medical specialists work together to perfect every generation of hearing technology. Did you know the earliest electronic hearing aids were large enough to fill an entire pocket just decades ago? Today's premium models contain artificial intelligence capable of recognizing different listening environments automatically within fractions of a second. Some devices stream phone calls, music, and television audio directly into your ears without additional accessories. Researchers now develop hearing aids with longer battery life, smarter processors, and personalized sound powered by advanced machine learning. Imagine a hearing aid that continuously learns your preferences, adjusting itself before you even notice changing background noise. Experts expect even smaller, smarter, and more energy-efficient hearing aids to transform millions of lives over the next decade. Think about this. Everything you've seen began as ordinary minerals buried deep beneath the Earth's surface. Thousands of skilled people, advanced robots, and years of research transformed those raw materials into life-changing technology. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.